Hey everyone, welcome to Chapter 3. This is the first video of Chapter 3. In this video, I will be explaining the difference between a vector and a scalar, and then explaining what a unit vector is. Okay, so to start, let's do a scalar first. A number that is known as a scalar, right, or a scalar number, is just what it seems or just what it sounds like. It's just a number. Right? It's a number, it's a value. You might hear the term magnitude. It's just a number. All right? It may have units associated with it. It doesn't have to. Let's see. May have units. I'll write it like that. So an example would be, well, you may have 6 apples, right? You can have 10 pencils, you can have 1 drink. You can be traveling or moving at 20 miles per hour, right? Those are all scalars. So, example, let's see, what did I say? 6 apples or 20 miles per hour, right? Those are all examples of scalars. The vector bit about it, right? To turn a scalar into a vector, you need to add one specific piece of information, and that specific piece is the direction, right? So you can say a vector is a scalar with direction. That's it. And this direction can be specified however, right? Along the x direction, along the y direction, 20 degrees north of due east. However you specify a direction, you give it direction, right? It becomes, that scalar becomes a vector. So then an example here can be, well, you can't really have 6 apples in the x direction. That doesn't really make physical sense. But the 20 meters per second, we can say due east. That's one way. Or 20 meters per second. I turned it into meters per second. It was miles an hour. Oh well. In the x direction, right? And I'll write this for now as x hat. I know I haven't explained what a hat is. I mentioned it previously, but I will explain it in 1 minute. Okay? Just know that this means in the x direction. Okay? So these are examples of vectors. Okay? Physicists use vectors to explain the physical world, right? It's a mathematical expression of their physical world, in essence, right? Or a part of it. They can do it numerically, like I've done here, or they can simply use arrows, like that, right? So this 20 meters per second, by the way, that's bothering me. I'm going to change units up there. 20 meters per second. There we go. Okay. So if it's just a speed, remember it does not have the bar above the v. 20 meters per second. But because we've specified direction now, we need to put that vector bar up top, and this direction has to be in the x direction. So we just need to make sure we specify that by, just saying plus x. Okay. You can say due east as well, right? However you want to specify direction. Another example is if you throw a baseball at some angle above the horizontal, right? So here's some baseball player and he throws a baseball and the ball launches from his hand. It will arc, right? We'll talk about that next chapter, but initially the initial speed or rather the initial velocity, I should say, can have some magnitude. Let's say he throws it 8 meters per second. That's actually pretty quick. But we need a direction. Well, typically we specify the direction in this case as so many degrees above the horizontal, okay, which normally would be the x direction. Okay, so that's another way to specify direction. Okay, now knowing the difference between a scalar and a vector, let's take a more in-depth look at a unit vector. All right, it's a special class of vectors. So a unit vector, just like its name might imply, is a vector of magnitude 1, right? Unit meaning 1. And physicists write them in the language of math as either I hat or j hat or k hat. Okay? You might also see it as x, y, or z. X, y, z hat, right? And by the way, this caret, right, is called a hat, just like a little hat, cartoon hat. And so this word here, or this symbol, is pronounced the letter I, hat. And so that denotes that whatever scalar that's slapped beside or that's associated with is in that direction. So for example, let's write an xy axis. Okay. If we have a vector, let's say little Timmy rides his bike, I don't know, 10 meters in the x direction or 10 meters due east. So we draw that like that, right? He has some displacement, so that is x. The magnitude of his displacement would be 10 meters, right? But to turn this into a vector, we put a vector bar on top, and then we write the correct unit vector after it. Okay, and so now we have a magnitude and a direction for this overall vector. Okay. I should mention too that some books might actually have an actual arrow with two little doohickeys above it, right? Other books might have just an arrow with one doohickey, right? Any of those three ways to write the vector notation above that symbol is valid, right? It all means the vector. Okay, so if you had, say, another displacement, if Timmy now moved, say, in the y direction, I have stuff up there. Let's say he moves south, or rather in the negative y direction. This will give us a good chance to do this. Let's see, if that is 1, now we have another displacement, x2, and because I've specified that, well, let's say up is positive y, his second displacement is down. That means, let's say he goes, that looks about half, let's say he goes 5 meters in the negative j hat. Okay. So you can turn this into minus 5 meters j hat, right? Or even just minus 5 j hat if you know the meters are assumed. Okay. All of these are valid ways of writing his second displacement. Okay. You could also write negative y hat. Again, that's completely fine. Some books will have I, some books will have x, and I may even accidentally interchange I hat and j hat in my examples. But just so you know, I is for x, j is for y, k is for z. Okay? So now that we have two perpendicular, by the way, two perpendicular vectors, and we've written them both in their full forms, right? If you wanted to find the overall or the resultant displacement, you could simply by the Pythagorean theorem, right? So to find, we'll say r, the vector, well, we need to take the magnitude, and I will explain that actually. Let's do that in the next video, right? I wanted to real quick show you, excuse me, this image here. These show you the projections, right? Or the components, in other words, of a vector in both the x and y directions. So say we have vector A here. Again, it's at a direction some degrees relative to the x direction. These A sub x and A sub y components, they are just that, components of this overall vector. And so if you were to write the full A of x vector itself, you have the magnitude, which is just the component of A in the x direction, times its unit vector, I hat. And similarly for the y component, A sub y times j hat. Okay. By the way, these components always must be less in magnitude. Their magnitudes always must be less than the overall magnitude of the vector, right? I will discuss how to break up these vectors into their components in later videos. So please watch those. Thanks for watching this. I hope you learned what a unit vector is.